27B, and it was 1 through 4. Number 1. Is the difference between two sample averages just due to chance? To help answer this question, statisticians use a blank blank z-test. So if you go back to page 505, it's a two-sample z-test. Okay? So it just, a one-sample z-test compares a sample to an assumed parameter. You guys understand that, right? That was chapter 26. And now we don't have a parameter, but we have two different samples and we compare them to each other. And the only added thing of that was the SE difference, which is the Pythagorean theorem. Okay. Number 2. In 1990 and 2004, the NEAP tested 17-year-olds on mathematics as well as reading. The average score went up from 305 to 307. You may assume the NEAP took simple random samples of size 100 in each of the 2 years. They probably took a lot more than that, but just to make things easy, we'll say 1,000. Can the difference between 305 and 307 be explained as chance variation? So number A, should you make a one-sample z-test or a two-sample z-test? 2. How come? You're comparing two samples. When would you do a one-sample z-test? One sample, two. Well, if we knew the box, we wouldn't bother taking a sample. So when do you do a one-sample z-test? When you compare a sample to what you think is in the box, right? You're going to compare it to a number that you think is correct, or, right, or you compare it to a number that you think is incorrect, right? Even if you think that the assumption is wrong, you still assume it to be true. Okay, so formulate the null and alternative hypothesis. What is the null hypothesis? The null hypothesis says 305 is the same as 307, or what you might want to say is 99 is equal to the 04 sample. Okay, and then the alternative would be that the 99 is less than the 04. Okay, so we need to set up two boxes. So in the first, we don't know what's in the first box. We don't know what's in the second box, but we had an X bar of 305 with an SD of 34. And the next box we have a 307 and an SD of 27. Okay. Which way do you want to do the difference? I would do 307 minus 305. Does it really matter? No. All it's going to do is either put you in the right tail or the left tail. I prefer the right tail because you don't have to deal with negatives and there's a lower chance of making a mistake. So I'm going to say, I'm going to call this sample my first sample and do 307 minus 305, and we need to divide that by the SE of the difference. In order to find the SE of a difference, I need the SE average for both A and B. So I'm going to take 34 divided by the square root of 1,000, and then I will do 27 divided by the square root of 1,000. And 27 divided by square root of 1,000. What do I do with those two numbers? Square them, add them together, and take the square root. So we'll do this number squared plus this number squared. And that number is always going to be a little bit larger than the other two, which makes sense because in the Pythagorean theorem, C is always bigger than A and B. Okay, so my SE of the difference is 1.37. So basically, I have a difference of 2 plus or minus 1.37. That's quite a bit, right? So I'm going to take 2 and divide it by this to give me a z-score. Why am I allowed to use the z-table? I have 1,000 draws. Okay, and I haven't taught you how to use the t-table yet. So I get a z-score of 1.45. What do I need to do with that? I need to shade norm from 1.45 to 5. I already know what the answer is going to be. The answer, my p-value is going to be larger than 5. Does everybody understand why my p-value is going to be bigger than 5? So in my normal curve, here is 0, and my 5% mark is at 1.64. And I landed at 1.45, which means the area will be bigger than 5. Okay? And with the z-score, you don't technically need to calculate the p-value. But with the other ones, you do. Because we don't have all of them memorized. We only have the z-table memorized. So if I shade norm, I would get probably, I don't know, 8% or something. Which means we accept the null, which means, did the kids get smarter? We don't think so. Chance error could totally explain what happened. All kids are stupid. There are no dumb questions, only dumb people. No, what does Mr. Dung say? There are no stupid questions, only stupid people and stupid answers. All right. Number 3. Number 3. In 1970, 59% of college freshmen thought that capital punishment should be abolished. In 2005, the percent had dropped to 35%. Is the difference real, or can it be explained by chance? You may assume that the percentages are based on 2 independent, simple random samples, each of size 1,000. Did they need to say independent? Why not? 35 years apart. Okay? And they're college freshmen. If you were a college freshman in 1970, then you are not a college freshman in 2005. Right. It's like those people who say, my freshman year of high school was the best 3 years of my life. Okay. So, in box A, which had 1,000 draws, we had a percentage of 59%. And then in box B, with also 1,000 draws, we had a 35%. We don't have an SD. What do we do? We can make an SD. How come? We have a percent, which means it's a 0, 1 box, right? So we're going to pretend that the box is 0.59 ones and then 0.41 zeros. And the other one's going to be 0.35. Okay? So I take 59 minus 35 over whatever I get when I do the SEs. So the SD is the square root of 0.59 times 0.41. Sorry. Okay, so square root of 0.59 times 0.41. What am I going to do with that number? The square root of the number of draws. So divided by the square root of 1,000. We should just memorize what the square root of 1,000 is. We do it a lot. So I get 59% plus or minus 1.55%. Okay, and then the other one, square root of 0.35 times 0.65 will be pretty close. And we'll divide that by the square root of 1,000. And I get 1.5%. Now what should I do? Almost. One's 1.55 and one's 1.50. So SED is the square root of 1.5 squared plus 1.55 squared. So I'm going to divide this by 2.159. So how far is 59 from 35? 5, 14, so 14. So 14 divided by the answer. What does that mean? Nope. No, the difference is 14 plus or minus 2.159. That 6.5 is a z-score. We are going to reject the null for sure, and we can even say the difference is highly significant. It's going to be practically zero. Right? If I have the standard normal curve, 0, and I'm way out here at 6.5, how much area is over there? None. So this difference is highly significant. So can we say that the opinions of freshmen in college with relation to capital punishment has changed? Yes. The opinions have changed a lot. Okay, number 4, a study reports that freshmen at public universities work 12.2 hours a week for pay on average, SD of 8.5. At private, they work 8.1 with an SD of 6.9. Assume these data are based on 2 independent simple random samples of 1,000. Is the difference due to chance? Okay, so my X bar for A is 10.2 with an SD of 8.5. Wow. What does that mean? Some people are not working and some people are working a lot. That is very spread out. When your SD is almost the same size as your average, there's a lot of spread. Okay? And for B, we have an X bar of 8.1 and an SD of 6.9. What can you tell me about the difference between public university students and private university students? Who works more? The public. Why? It's probably a social status measurement. If your parents can afford to send you to a private university, you probably aren't going to work as much as somebody in a public university. And private universities are lots more expensive than public. It's called a charter school. So in Utah, in Utah, they tried to do what was called a voucher system, and it was shot down by the public. So a voucher system says every student gets this much money, and if your kids are not enrolled in a public school, then the state will give the parents the equivalent amount of money to help pay for private school tuition. And it failed miserably. So then they created these charter schools, which are kind of, they follow a different set of rules, and they're public schools, which means the state the state takes the money that they would have given to a regular school district and they give it to this charter school, which isn't part of a school district. It's its own entity. Right. Yeah, so they don't have so so charter schools work under a different set of rules. They don't have, for the most part, they don't have transportation costs. One of the deals is if you come to our school, you pretty much have to show up by on your own. They don't have a lot of administration. Well, they do because they got to go to activities and stuff. But for school, some right, but it doesn't service everywhere. So yeah, their administrative costs are a lot less. So what ended up happening is when Utah allowed for charter schools, every private school became a charter school. So they can use state money and still charge the parents in some cases. In some cases they don't. So it's kind of a semi-public school. They work under a different set of rules. The teachers are not part of the state retirement package, and that makes it a lot cheaper. So every teacher in the Emory district gets, well, they get money from the district sent to the retirement office. Well, they will have to set up their own accounts and save their own money. So running a charter school is much cheaper than running a public school because they don't pay their teachers as much in some cases. They don't have the retirement. They don't have a district office. They don't have, you know, yeah, they're a much smaller group and they don't offer as much in a system that a school district does, which means they have money to do other things. Did they? Oh. Hmm. Okay. I didn't know that. All right. So is the difference due to chance? So my null is going to be that A is equal to B, and my alternative is going to be that A is greater than B. So yeah, yeah, basically. Or actually, they're doing difference, so they would say the difference is 0. So you could also say that the difference equals 0 or the difference is greater than 0. It doesn't really matter. I mean, the whole point is to answer the question. So however you set up your null or your alternative, it's really not important. So 10.2 minus 8.1 divided by the SE difference. The SE difference is going to be the square root of, or sorry, 8.5 divided by the square root of 1,000, and then 6.9 divided by the square root of 1,000. So 8.5 divided by square root of 1,000, and 6.9 divided by the square root of 1,000. So I'm going to square root the square of both of those, plus squared So I get 0.346. What do I do with 0.346? Put it right here. So 10.2 minus 8.1 divided by 0.3462. And I got a z-score of 6, which means we reject the null. We say the difference is highly significant, which means, do public school attendees work more than private school attendees? Most definitely they do. Yes, they do.